Good morning, everybody. I don't think I've been more nervous to talk in front of a group of folks the whole time in my career. This is home to me. This is the field day that I attended as a boy. And in fact, I can remember probably the last one I remember well was at the Carowinds farm in Swan Quarter. And Dr. Heinegger's technician at the time was preparing for the Blacklands tour, and he was spraying with a backpack sprayer. And I said, who in the world would want to do that? And then 1 year later, about a year later, I started working for Dr. York, and I don't think I took off a backpack sprayer for about 5 years. So I learned very well and very early, don't say what you're not going to do. But anyway, I appreciate the chance to come back and speak to y'all, and appreciate Wes. Wes and I are going to hit on some of the weed updates. We had something planned in the field for symptomology, but symptomology just doesn't do it justice to throw up some slides on a PowerPoint. So we're going to move into some hot topics in the weed control front. I'm going to talk about the dicamba or auxin update, and then Wes is going to talk about where we are as far as resistance is concerned. And also, side note, Kyle Potter is in the audience. This is my cousin. I told him I would make him famous with this picture. This was taken in Hyde County a couple Christmases ago. This picture has been to Delaware, Maryland, Tennessee, I don't know, Georgia, all over the place. So it reminds me of this day with all the wet going on in the background there. So just an update on the auxin situation. This is communicating with NCDA. These are the official complaints that we've had across the state. They have 8 official complaints, 3 of which are on soybeans, primarily from dicamba injury, 2 on grapes, 1 on tomato, and 2 on tobacco. And that 2 on tobacco is actually, I think, from the same part of the world and the same grower. So overall, we're in a fairly same shape we were last year at this time, maybe a little bit less. But one thing you'll notice is the issues we're having on the specialty crops. That is unacceptable. So we need to be on the lookout for especially making these applications around something like tobacco or vegetables. Kind of backing up, talk some observations from Wes and myself. Y'all do a great job of working things out on the turn row, and that's a really great thing when you have these issues that happen farm to farm. I think communication is key to avoiding a lot of the issues that we're having. But Wes and I do get a number of more complaints that we just hear about through the grapevine. Wes has heard of about 10 to 12 dicamba complaints to soybeans, estimating 500 to 1,000 acres injured. I've heard of 1 dicamba complaint to cotton. Very small amount of dicamba injuring cotton across the state. I actually think that was from a pasture application. And then, not to be partial, we have had some issues with 2,4-D. I've had about 6 complaints on 2,4-D moving to injuring cotton. Only about half of those were cotton to cotton. The rest of them were pastures or roadsides or something of that nature. So I'm estimating about 250 acres of cotton in the state injured by 2,4-D. The situation across the nation is much more dire. They are having the last update that Dr. Bradley did at the University of Missouri estimated that there's 1.1 million acres of soybeans affected by dicamba across the nation. This is probably less than we had last year at this time, but still 1.1 million is a significant part of our soybean crop across the nation. And you'll notice in the southeast we've done a good job of keeping it on site with very few complaints and also very few acres of effect. So I think one of the successes we had was our face-to-face training that Dr. York and Everman and Dr. Jordan did across the state in conjunction with NCDA. I think it served the growers very well in educating y'all and trying to keep this stuff on your farm and on your fields and off your neighbors. But I wanted to revisit one of the topics that was covered in those auxin trainings, and that is the dealing with temperature inversions. A couple of cases that I've walked have been large scale, hundreds of acres affected. Hundreds of acres are not injured to a point of no yield or complete yield loss, but we do have, that border effect from the source where we probably are not going to pick much cotton in the cases that I've walked. But I've attributed them largely in part to some temperature inversions. Now, why in the world should you be worried about a temperature inversion? Well, if you do a Google, and that's a scientifically acceptable research, for temperature inversions, you'll find a lot about hot air balloons. Apparently, these things make a hot air balloon ride quite interesting. They probably didn't worry too much about a temperature inversion until somebody got caught in them. And you probably won't worry too much about a temperature inversion until you have a situation where you have a large plume of this stuff move a half or 3/4 of a mile and injure hundreds of acres of cotton or soybeans. So that's why you should be interested in temperature inversions. This is a case that I walked in Virginia. I would say this is a perfect scenario for one of these things to happen. This was in right around the North Carolina line. We had about 150 acres of extend soybeans. This is actually on a hill. So I threw up the topo map, and you can see where the lines are closer together. That means it's steeper, so it's higher in elevation. There's also a little river here, a little bit of that river effect on the temperature. And basically what we had is about 50 acres of soybeans across the river, where when they made this application on the hill, we had a temperature inversion set in, and we basically ended up with this whole field injured by dicamba, except for a couple of corners that were kind of away from the wind direction. But anyway, these things are real head scratchers, and I really would advise you just to be on the lookout for them or take them into consideration before you start making that decision to spray. So just to kind of recap of what a temperature inversion is, the normal conditions, and this is what we're after, and this is what is the typical situation, is the sun heats the Earth's surface, it warms the air by the surface, and then we have normal mixing of air above it, so this turbulent mixing. So basically, the air gets cooler as we increase in elevation. Warmer air by the surface, cooler air above, cold air really high. And just like its name, a temperature inversion means the exact opposite. We have colder air by the surface, and a lot of these things set in on clear windless nights, and they're called nocturnal temperature inversions. And it's basically the exact opposite of what we see in the daytime. So we have radiative cooling by the surface. It creates a cool air, pushes that warm air up, and it gets sandwiched between the cool air by the surface and the cold air above it, and it creates a ceiling. And this is also facilitated by the lack of wind. And this ceiling can be really important for capturing some of the stuff you've been spraying on your fields, and it's something that we've really got to be on the lookout for. But I had a hard trouble wrapping my mind around temperature inversion, so I went looking for something that I could show to growers to demonstrate it in real time that would kind of hit home a lot better. And it's amazing what you can find from a 6th grade science teacher. This is just a simple science experiment using cold water and hot water, and I just used a little bit of food color, and I actually raided my mother-in-law's kitchen to find all the things that I needed to put this experiment together. But it's a really good demonstration of a temperature inversion, and really hits homes to just kind of show you what this thing can actually do. So we got 2 videos here. Here's the first one. I'm going to get my tech guy to play it. The blue water is cold, the red water is hot. All right, this is normal conditions where we have warm air by the surface and we have cool air over top. Photo and video credit goes to my wife. This is what we want. This is normal conditions. That warm air rises, mixes with the cold air above, and this is the normal situation where the pesticides that we're applying on our fields can dissipate like they should. All right, this is the temperature inversion, the exact opposite. I've got the cold air on bottom and the hot air or the hot water on top. And there you go, no mixing. So what in the world does this mean to you? Well, if this situation plays out on your farm and you spray something like dicamba or 2,4-D and those suspended particles or however it gets caught up in that inversion, they can just hang around at that ceiling. And then if we get a light wind that blows through, that can move a whole plume of this stuff off site. Now, I know y'all are thinking, well, there ain't a time in the Blacklands where the wind doesn't blow. That's not true. If I've heard it once, I've heard it a million times from Daddy. I'm going to get out and spray early before the wind kicks up. And if you're spraying some of these technologies where we have crops that are super, super sensitive, you may be causing a bigger problem than we would if we had a little bit of wind out there later in the day. And there's just a final product to show you the inversion versus the normal conditions and that layer that will not mix. Now, there's been a lot of information on these things across the United States. This is some information from Missouri. When these first things, we started talking about these inversions, we really didn't know much about them. We had to bring some weather guys in on it. But they actually occur, these nocturnal temperature inversions occur a lot more than we think. This is from the Boot Hill, Missouri. And we'll notice in June and July, in 2016, they had 24 occur. And in July, they had 20 occur. So 2 out of 3 nights, we had a nocturnal temperature inversion coming in. And a lot of times, they'll sit in at 5 or 6 o'clock and run up until the sun rises. And this is just another slide showing how long they can last. Again, if you think you're getting out there before the wind kicks up in the morning, you may be actually making a decision that's more harmful to your neighbors. And then this was interesting. I was in West Tennessee last week, and they were talking about these temperature inversions as well. And they did some research on their farm in West Tennessee, and they actually put one of these weather stations on top of a hill and in a bottom. And they found that there was a big difference in landscape. Landscape had a big effect on these temperature inversions. They had 18 temperature inversions on the hill in June of 2018, 22 in the bottom during June of 2018. But what was interesting is the ones in the bottoms oftentimes dissipated later. Now, I know that's not much of a concern for y'all with our flat topography, but if you've ever noticed fog early in the morning, it kind of hangs around field edges, so this same thing can play out in our fields. It's just that fog is just could simulate how that pesticide is moving. And that might be why we have more injury along a tree line. Some other things that can come into play are cool air drainage in front of a weather front, and I think that caused some of the worst cases I saw this summer. But again, this shows you that there's a lot of factors that go into keeping these applications on site. So some things to watch for. No wind or very slight wind. This is why those labels have, requirements for a 3 mile an hour, at least a 3 mile an hour wind. Clear windless nights. A lot of times if you see low-lying fog, that indicates that a temperature inversion is going on, visible dew, horizontal smoke patterns. And these things are capable of moving very long distances, half a mile, 3/4 of a mile. A lot of folks will say, oh, I had physical drift that went 2,000 feet. That's probably not the case. And most of the research that's been done, physical drift only goes about 600-700 feet, where these things can move a very, very long ways. And one thing I know most of y'all have probably experienced, if you've ever been picking soybeans late in the evening as the sun's going down, the dust will not dissipate. That is a temperature inversion, a classic example of a temperature inversion. And you got to basically stop the machine and let the dust go by you before you can start picking again. So I was going to go ahead and head off this question before anybody asked. Several phone calls here recently. Will we keep the technology, specifically dicamba, which registration runs out here in the fall? If you look at North Carolina as a whole, and I know Wes will agree with me, I think we've been good stewards of it. I think we've done a good job outside of the issues on tobacco and specialty crops. We have to have a zero tolerance policy for those crops. But I think we've been good stewards of it and deserve to be able to keep it. But is 1.1 million acres of soybeans, and this number will probably go up as we move into August after the July numbers come in and August numbers come in, is that acceptable in the eyes of the EPA? I felt confident that we would keep it. After last week being in West Tennessee, I'm not so sure. So guys, this is, and I hope Wes will touch on this a little bit, this is one of those hot topics, just like nuisance laws in the hog farms, that this is, this could be a black eye that people start attacking. So we need to do a good job as far as keeping this stuff on site. And with that, I'm going to turn it over to